Hello, boys and girls, and welcome to our Chapter 4 review. Now, before we begin, I know everyone's going to be very nervous because I haven't been at school this week, but don't worry, you guys are going to do great on the test. As I've told you, you're probably the best proofwriting class, top to bottom, that we've had, and this test is heavy on proofwriting. So I know you're going to do a really good job. Do you hear Zane in the background? He thinks you're going to do a really good job too. So we're going to go through. The test will cover sections 4.1 through 4.6. Now I know that we didn't do 4.6 together, so the material that I put on 4.6 will be simpler material than normal. So it might be something like this. Well, we'll get to it in a little bit. But it'll be something easy like that. Did everyone say that x would be what? 180 minus 40 gives me 140 divided by 2. Did everybody get 70? Okay, good. Anyway, let's begin. There will be some easy questions from 4.1 because there's no way for me to make 4.1 difficult. Remember, we classify triangles by angles and we classify triangles by sides. So if we classify by sides, what are the possibilities? If no sides are congruent, we call that scalene. If it has two or more congruent sides, we call it isosceles. And if all three are congruent, then we call it equilateral. So the only fun type of question that I can put on here might be a coordinate question, where you get to use either distance formula or Pythagorean theorem to then classify it by its sides. So I might give you three coordinates. I'll make some up here, and we won't do the whole thing so that we might get through this. Alright, and then you would plot those. So I'm going to go to 3, 4. That looks about right there. That looks about right there. That looks about right there. I gave myself a nice horizontal line at least. Alright, and then you would find the distance here, the distance here, and the distance here, and then use these three definitions to do it. Either scalene, isosceles, or equilateral. And this one looks like it is scalene if I had to go by looks. But don't go by looks. You'll have to justify it by some method. Alright, the other thing that we did is we classify by angles. And we actually have 4 of those, if you remember. If all angles are acute, then we call it an acute triangle. If it has one right angle, then it's a right triangle. And if it has one obtuse angle, then it's an obtuse triangle. And then the third type is if all the angles are the same. Remember, that's an equiangular triangle. Now, I can try and try and try, and there's no way that I can make this a tricky question. So this should be an easy one for you. So everybody should feel good about walking out of that test tomorrow with at least like a 12, because you get a couple of these right. I'm kidding, you'll do much better than 12. Alright, moving on. In 4.2, that's where we formally introduced our good friend, the triangle. Let's write it out. The triangle angle sum theorem. And remember, that's where we said that all triangles, interior angles sum up to 180. This was also a theorem that we proved in class. So let's look really fast at how we did that. We started with some plane triangle. And then we drew an auxiliary line. we did a special one. We did it such that it would be parallel. And then we had alternate interior angles congruent here and here and here and here. This made a straight line adds up to 180, which means these angles added up to 180. And that's something that you can look at in your notes. Now, I'm not sure if this proof will be on there or not. There's another one later on that I like as well. But this is one that you'll want to be able to make sure you at least understand all the steps. Now, the other big thing that came from 4.2 was the exterior angle theorem, maybe? Alright, and that just says that if you take a triangle, so let's do that. Let's take a triangle. Alright, and we're going to create an exterior angle. So the way that I create an exterior angle is by extending that. So remember, exterior is outside, so here's the exterior angle, and then we call these they're interior angles, but they were far away from that angle, so we call them remote. And remember that the exterior angle is equal to the sum of its remote interior. So the measure of angle 1 would be equal to the measure of angle 2 and angle 3. Now, I told you this wasn't a super big deal through all your geometry life if you ever forgot it, because you can always use the triangle angle sum theorem. Now, this would not be. Nope, not yet. All rats. Things kill me. There we go. That's going to work. All right. So remember, I told you it's not the worst thing in the world if you forgot it. If I know that this angle here is 40, and I know this angle is 110, all right, and I was trying to find x, then if I remember that, then I know it's 110 minus 40 equals 70. Boom, that was easy. All right. Or I have a linear pair, and then all triangles add up, so that's 40 and 70 makes 110. 180 minus 110 is 70. So see, whoops, that's a 7. So this and this I can get either way. This one was faster. So long term, you forget that. It's not a big deal. So basically, the reason I'm showing you all of this is I will put some sort of problem on there. Like, remember the quiz that we took a long time ago? I think was it the Friday before Thanksgiving? No, we did the fun puzzle that day. It must have been the Thursday before Thanksgiving. All right, but it had some different angles for you to find. Using different techniques, I guess is a nice way to say it. That's what we'll have tomorrow. Alright, so it could look like this. And I can give you different information you go through and solve. But those are the two techniques that you'll use. Triangle sum to 180. And your exterior angle sum theorem. Alright, so 4.3, or maybe I'm getting my sections mixed up. I don't have my book. Let's see, it's... Okay, now I remember. 4.3 just talked about congruent triangles. And so that's not super big on the test, because when we did 4.3, remember what we said was, this is going to work, I promise. Okay, there it goes. Maybe not. Uh-oh. So, anyway, I will continue to try to make this work and move forward. So, what we said in 4.3 was in order to show that two triangles were congruent, we had to know that all 6 parts were congruent. But when we got to 4-4, we only needed 3 parts. And we had the specific parts that we needed. There we go. I knew we could figure it out. Okay, good. So sorry about that. Delay in 4-3, it's congruent triangles. And we needed all 6 parts. So really the only thing, the big takeaway in the end, since we learned 4-4 and 4-5, is that if I give you a congruent statement, let's see, how about TRY, right? Then if you see this, you should be able to tell me 6 things. And those 6 things that you should be able to tell me are angle F congruent to angle T, angle I congruent to angle R, angle X congruent to angle Y, and FI would be congruent to TR, and IX would be congruent to RY, and FX would be congruent to TY. So tomorrow's part from 4-3 won't be all that big, except that's what we really learned about this. The congruent parts of congruent triangles are congruent. Alright, that came from here. And if you want to continue to use def of congruent triangles instead of CBCDC, that works for me. And of course, I always like to write it out like this. Corresponding parts of congruent triangles are congruent. That's my favorite. Glad I've got the pen working. So let's look at 4-4 and 4-5, because that's probably where most of the tests will come from, because it's on writing those proofs. In 4-4, we picked up side, 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 and side, angle, side. And then in 4-5, we picked up angle, side, angle, and angle, angle, side. At some point before the exam, I'm going to teach you another one called that, but that won't be on the test tomorrow, and we'll work on that. That toolbar is not working. That's just not good. But we figured it out. We can do it from the top. So your proofs tomorrow will have paragraph proofs. Remember, they're a little less informal. You're just explaining what you're doing, just like you're talking to me, just like I'm talking on this video. You'll have 2 column. That's a good way to organize. And you'll have flow. Now the flow proof probably won't be fill in the blank flow like it was before, because I think that was confusing to some. You'll probably have to write this one by yourself, and you would write that one by yourself. And this one you might write by yourself, or it might be fill in the blank. Right? And remember, well, let's say remember, it's going to go in, varying degrees of difficulty. Oh no, let's see if I can do it this way. Tools, really tools, shape, give me a triangle. Alright, and then I have to go tools and pen. Yeah, this is just not convenient. Alright, so the very simplest of them, well, I don't have to do this all the time. The very simplest of them would just be proving 2 triangles congruent. And that would be using, now I don't know if I can, nope, oops, don't do that. Sorry. This is not going well. Okay, we got it. That was easy. I don't know, you guys are lucky. This might be the worst video ever made. You're getting to witness that. That's kind of fun. You'll probably want to go back over Christmas break and watch this again and again. Okay, so the very simplest ones would just be proving triangles congruent. So if I wanted to run through that, all right, I might be given, let's say that AD is congruent to AB, and DC is congruent to CB. And the proof might be as easy as just the triangles. Triangle ADC, whoops, is congruent to triangle ABC. Okay, and so this would be an easy one. In different ways I could do it. I could say, okay, that guy is congruent to that guy is congruent to that guy. Hey, it's my good friend, the reflexive property. These triangles are congruent by side, side, side. And that would be an easier one to do. And then we'll also ramp the level of difficulty up. That toolbar just stopped working crazy. All right. By asking you to do something else, to actually use the congruence. So I might ask you to prove AC is perpendicular to DB. Now, the way that we do that is we use the congruence part of it, or the fact that all 6 parts would be congruent. So I can still go through and show those triangles are congruent by side, side, side. I thought I might show you a different way, though, just for fun. What kind of triangle is the big triangle ADB? If those 2 legs are congruent, it's isosceles, right? Which means the angles opposite those sides are congruent. So if I was really wanting to have some fun, I could say angle D is congruent to angle B by the isosceles triangle theorem, which, if you remember from that fun video that I did for 4-6, was that if the sides are congruent, then the angles are congruent. Then I have the triangles congruent by side, angle, side. And now let's look at how we get that part, how we use the congruence. I would know that angle DCA is congruent to angle BCA. Why? Because the corresponding parts of congruent triangles are congruent. And then I would know that AC is perpendicular to DB because perpendicular lines form congruent adjacent angles. But that's how the proofs will step up in level of difficulty, will be not just showing that triangles are congruent, because while that's fascinating, that's not really particularly useful unless we are going to use that congruence. So you'll have some just as simple as proving triangles congruent, but then we'll step it up and use that. Let's do another one where you use it, and then we'll talk about 4-6, and then we will wrap up this terrible, terrible video. All right, I'm going to stick to the pen instead of doing shapes, but bow tie looking thing is always popular. We have triangles like this, and let's call this an ATHY. I'm feeling kind of mathy, and so you might be given, let's see, let's do T is the midpoint of, let's do MY and AH. Let's prove that MA is parallel to HY. So, I'm going to try to change the pen color. Let's see if it works. So far, so good. Yay. All right. So since T is the midpoint of MY, I would know that MT and T8 are MT and TY are the same. Now remember, since we're going for congruence, I would use midpoint theorem to justify that. And same thing for AT and TH. Again, those would be congruent by midpoint theorem. Now, please remember there's no such thing as third side theorem. We have a third angle theorem, but we don't have a third side theorem. So you don't know that MA is congruent to HY. So the side is out. What we do have is our good friend vertical angles here, there, and there. So I know that angle MTA is congruent to angle HTY because vertical angles are congruent. So my triangles are congruent because of side angle side. And this is the part that we've done hundreds and hundreds of times, or at least it seems like we have, and that you all are very good at. So the fun part tomorrow will be using that. So how do I show that lines are parallel? If we can show that any of the special angle pair relationships are true, then the lines are parallel. And the ones that I'm talking about is if you can show alternate interior are congruent, or you can show that corresponding angles are congruent, or if you can show that alternate exterior angles are congruent, or if you can show that consecutive interior angles are supplementary, then you have yourself a set of parallel segments or lines. And so for us, if I write out this triangle congruence, which I'm going to do, triangle MTA is congruent to triangle, and let's check. From M to T is one congruent mark, so that means I need YT, and then from T to A is 2. So the way I originally named the triangle, I'm going one congruent mark, two congruent marks. So I have to go one congruent mark, two congruent marks on the other. So that's going to be YTH. So this is a big step, making sure I get the congruent statement right. I didn't have to do MTA first, but once I did MTA, I had to do YTH. And that's another big takeaway from 4.3, I guess, that I didn't mention before. So now, what angle is congruent to angle M? Angle Y is. And what angle is congruent to angle A? Angle H is. Oh, neat trick again. So these are not congruent because they are alternate interior angles, right? That is not why those angles are congruent. They're congruent because the corresponding parts of congruent triangles are congruent. And since those angles are congruent, now I know that the segments are parallel. Because if the alternate interior angles are congruent, then the lines are parallel. So we had a very similar quiz on, this similar proof on our quiz. Remember, it was the flow proof. And so you'll most likely see something like this tomorrow. And then you might even most likely see something like this on the exam because I must really like it. All right, one more section, and then, like I said, we'll wrap this terrible video up. 4.6 was isosceles triangles. We didn't get to do the lesson together, so it won't be heavy on that. You should be able to solve problems like this. If this is 30 degrees, and that's x, then you know that these two angles are congruent, so they're sharing the 150, so each of those are 75. you should be able to do that. And you should also, if you needed to and approve, know that angle B is congruent to angle C by either you can use isosceles triangle theorem, or you can do what I like to do and just do the symbols. And then if you're using the converse, using the angles for sides, and then you just reverse it. And then you never have to remember which was the converse and which was the original. So our homework tonight is on RenWeb. It's the practice test, but I've omitted the ones that we didn't cover, which is in 4.7, which you'll do in Algebra 2, so we probably won't look at that. And in 4.8, which I'm going to find time for us to do because I really like those coordinate proofs, but we don't want to get bogged down before the exam with them. So I will not be there in the morning. Most likely won't be in tomorrow at all. So you can email me questions. I don't want to try to do something fancy like posting to Moodle or anything because we haven't done any sort of discussion like that. Maybe that's an idea. Maybe we'll try that again. We'll have to practice that. We'll practice setting up a session where we're all live online on Moodle so we can have a forum that way. But for tonight, just email me questions, all right, and make them very specific. If you need to take a picture of the problem and attach it, then do that because I don't have my book, and I will answer them. But really, you guys should be very confident about how you're going to do on the test tomorrow. It's going to be very proof heavy, but you guys are really good at writing the proofs. All right, good luck, and I'm going to try to stop this terrible recording now.